Hey, I'm Tim Carr. Getting close to the end at the vBrownbag VMworld 2016 Tech Talk schedule. I guess it's day 3, so first of all, before I get going, I definitely want to say a big thanks to all the people that make the vBrownbag happen. This is an awesome opportunity for people who want to learn how to speak in public, number 1. And number 2, this is even better of an opportunity for people to learn something new. And that's what we're here to talk about today in my session called Container This. A lot of people have heard about Docker containers. A lot of people want to do Docker containers, or maybe a lot of people don't know what they're even going to use a Docker container for. So today we're going to talk about some of the very basics. I'm Tim Carr. You can find me on Twitter at TimmyCarr, or www.timcarr.net for my blog, where I talk a little bit more about some of these things that we're going to talk about today. So first, let's set the stage for why. When I talk to customers who have started down the container route, a lot of times it's because software companies had a deployment pipeline that maintained state of the end state of production by using things like configuration management, stuff like that. Now, there's nothing against configuration management, puppets, chefs, they all have their place, but integrating stuff like that into the deployment pipeline can actually create a bottleneck. And not only that, it can create the same kind of silos within an organization that cause people not to be able to get code into production. That passing of the code from the development team to the ops team is really the kind of thing that we're trying to avoid when we're looking at containers. And the net of that is that no matter how hard people work, no matter how automated pipelines became, there's still a little bit of friction between the development and the operations teams. So, in steps containers, and I have the Docker whale up there mainly because, and I don't want to start a firefight, but the community as a whole has, while there are a lot of container platforms, the community as a whole has kind of said, okay, Docker looks good, we're going to leverage that. I'm not saying that's the best reason to leverage that platform, but it's certainly the most consumed platform. And really, that's kind of what we're going to focus on today. So containers give us 4 things, right? They're fast. I can instantiate a container within seconds, right? They're super efficient. They take up very little space, and they use layering technology to ensure that only the things that you need to get on your system come down to your system to make that container execute. They leverage process isolation. And we're going to talk about process isolation just a little bit more, but the important thing to understand is that leveraging native kernel technologies, processes are isolated from one another in what we call a container. And finally, they're portable. And that's kind of what we're going to get into down the road. But realistically, before we do that, let's talk first about the difference between VMs and containers. So, I'm a VMware nerd. There's a lot of people here who are VMware nerds. A VM gives us logical separation of a virtual OS from a hypervisor, right? So what we do is we spin up this box that runs our OS, right, on a hypervisor. Now, a container logically segregates its instances in the OS, and that's important to understand. So the Linux kernel, if you're running a Linux implementation of Docker, is actually maintaining the separation between your different containers on the operating system. It's not completely unlike VMware, but the main difference, and I heard this at the Docker booth, and I think it's super. Docker containers are like an apartment building. There's plumbing for the whole apartment building. There's electric for the whole apartment building. These things called shared services. I like to think of that like storage and networking. Each machine that you have is a shared service. A Docker container is like an apartment. That apartment fires up and leverages those shared services. Let's talk a little bit about building, shipping, and running. This is really one of the main advantages of Docker, right? So on the left, we've got our developer who finishes writing code and then checks it into a GitHub repository. That GitHub repository there is where we're going to maintain state. That's where we're going to maintain all of the information that we need to run our application, right? The one thing that you need to know about what actually goes into that GitHub repository, though, is that the developers created this thing called a Docker file. That Docker file determines all of the things that you need to have within your container so that that code can actually execute. So what we actually have is we have the developer finishing writing their code, but then also defining what the end runtime state should be within the code. Now, you'll notice earlier we talked about one of the big problems. One of the big problems is passing the code from the dev team to the ops team and getting that actually deployed to production. Here, the developer is actually able to say, well, my runtime should look like this. I'm going to define that within a Docker file, and then we're going to build the container. And that's that next little whale there. What that is that's an image repository, and in this case, that's going to be Docker Hub. Docker Hub is a hosted service. There's certainly on-prem services that you can use for what we call a registry, but that Docker Hub there is where we actually build that container and make it ready for consumption. So in a previous video, the EMC team talked about a container for Minecraft. So what they're doing there is they're actually storing the Minecraft code and that Docker file for Minecraft in a GitHub repository, and then it's being built by Docker Hub. So when you do a Docker run, if that image doesn't exist on your system, it's pulling that down from the repository. And we're going to get into that in just a second. So the final step is actual deployment. And what I'm showing over there is just a bunch of containers running. And that's how I want you to think of it, because there are so many different container management and container execution platforms out there that it's really irrelevant. It's choose your own adventure, and that's kind of a deeper topic of how you might want to schedule containers as a whole. So up there, that's the Amazon Elastic Container Service. There's certainly other scheduling algorithms to let you do this stuff on-prem, right? And I think those are all very valid too. But either way, this is signifying a code delivery pipeline. If you'd like to know a little bit more about a code delivery pipeline, I encourage you to look at Byron Schaller's earlier vBrownbag talk from today. That'll be up on vBrownbag.net, where he talks about all of those release cycles. He did a really great job of outlining what it would take to get your code promoted all the way through. And building a container just plugs right into that pipeline as a whole. So, what happens when a container is executed? Now, this is kind of a hard slide to put together. So let's start in the middle. You see that Docker engine process? That's a engine that acts and puts an API out on your host that is called by the Docker client. So when you're on your command line and you're typing these Docker commands, you're actually using a client. That client is sending its API data to a Docker engine, and that Docker engine is in charge of instantiating a container, stopping a container, telling you what images are on the host, all of those sorts of things. So once again, the Docker engine process is kind of the broker for all of the other services. You're simply just going to use the client to talk to that through an API interface. An interesting note, you don't have to use the Docker client if you don't want to. Those APIs are available for you to leverage. If you wanted to write your completely own client, or if you wanted to integrate this somehow into some other system, you certainly could. So that Docker engine process, let's assume that we've never run the container that we wanted to run on this host. That Docker engine process is going to look at the local image repository that's contained on every Docker instance that you're going to launch. It's going to look there and it's going to say, hey, do I have this thing that I need to run? And when it finds out, no, it doesn't have that thing that I need to run, it's going to issue a pull command from either the registry that engine is pointed at, or some other registry. And I say that the registry that engine is pointed at because you can point it at a number of things. This is a choose your own adventure thing. There are many people that have their own versions of registries. You can run one locally. You can run one in the cloud. You can leverage this as a service by using Docker Hub for private repositories. You can even use an Amazon one that's out there. So you have to configure your Docker engine to understand what registry to leverage and potentially in what order. So finally, when it talks to that registry, the first thing that it does is it tries to figure out only the layers that it might need to download to execute your container. And I talk about layers here because I'm going to show you in a second what a Docker file looks like. The point of Docker is that they can take many different images and I'll layer them all one on top of the other. So for example, I think I have it next here. Yeah. So this is an example of a Docker file. You can see that this says from Ubuntu 16.04 at the top. right? What that's saying is, get me the layer that has that. There might be something else. So let's say you didn't want to use Ubuntu. You could use any other image. You could even use an application image. Maybe you would say from MySQL. MySQL, when you download that from the registry, is going to know what its prerequisites are. So if it has for some reason to get something else to be able to run, you're going to see during the pull that it's going to get all of those other prerequisites as well. And we're going to get into that in just a second. But back to this. So we're downloading our image layers from the registry. And then ultimately, after that's all done, we're going to execute that. Now, the Docker engine process is actually in charge of executing that to your specification. You saw earlier in the EMC presentation that they wanted to expose some ports by using a port mapping command. You can certainly do that. There are a lot of other things you can do as well when you instantiate a Docker container. You can create a local file system and mount that. You can mount a file system through to your container. You can do all kinds of different things. Really, the docs are a great place to start. And this is just an introduction. Ultimately, the container runtime is executed here, and you get your instantiated version of the container. Now, once again, this is a shared services model. That Docker engine process up there, that is a process that's running on a Linux host. So each of these containers on the Linux host are separated by these things called C groups and so on and so forth by the kernel, maintaining a little bit of separation within the OS. But the thing that you should understand is that should the Docker engine be compromised on each host, you're in trouble, because that is the thing that has access to everything. Docker engine generally runs as a root type process on your environment, so should that become compromised, your box is owned. Be mindful of that, especially when you start looking at more advanced things, like exposing your actual Docker port externally. I don't recommend that. You need to make sure that you understand exactly what your Docker engine is doing before exposing that port. It's a quick way to get a box hacked on the internet. So, word of warning. So, once again, creating your own container leverages a Docker file here. And you can see here I'm using Ubuntu 16.04, and what I'm doing after that, after it downloads Ubuntu 16.04, it's going to run all of these commands that I have. You'll see there that I'm going to do an apt-get, I'm going to do an update, I'm going to install some things, some packages that I need to install. But finally there, I'm running a curl command to go out to GitHub and get a package from the PowerShell repository. And then I'm going to install that. And then finally, that entry point right there is ultimately the thing that this container should do by default when you execute it. So if you were to type docker run after you build this container, that container's name, you're going to end up executing that thing there called PowerShell. And the reason why I'm doing this is I want to show everybody how they can build the new open source PowerShell on a Linux box and execute that. And that's kind of what my demo is going to show off right here. Unfortunately, vBrownbag, we have to be very mindful of the tech that we're using here. So what I did is I made a quick video of me doing this last night, and I'm going to walk you through all of that. So here we go. This is my Mac computer, and I've sped stuff up here because my hotel Wi-Fi is awesome, just like yours. And so ultimately, what we're doing right now is I'm cloning a GitHub repository for PowerShell, and you'll see after moving into that repository that boom, right there's a Docker file, okay? And that Docker file happens to be the Docker file that we just looked at, right? But kind of just to prove it to you, let's open it up, check it out. Yeah, you can see we're going to run Ubuntu 16.04. We are going to have an entry point of PowerShell, and we're going to, and we're basically just going to keep moving. So let's move that right along. So if Tim could type faster on a video, ultimately, we're going to build a container locally. Now, if this were a CI, if this were a build pipeline, this is something that can be done off of your host, but this is also something that you can do locally, and I wanted to show you what that looks like. So I'm building that container. Right here, you're seeing all these gits. These are all of the file system things that are needed, and ultimately, all of the things that it needs to build up a container, right? And you can see we're already at the point where we're running that curl command, where we're getting the PowerShell stuff, and now we're actually able to show, and this is kind of interesting, all of the things that were needed to be downloaded to get this done. There's a couple other ones there, but you can see PowerShell at the top, and then you can also see Ubuntu down there, right? So that Ubuntu image happens to be the image that was a prerequisite to mine, but I built another one. So in my image repository, I have the original Ubuntu, and then my new layer, which is my PowerShell layer. And so if you were to push this up to Hub, and you just want to run PowerShell, it would know all about that. Finally, we run the container, and you can see, boom, PowerShell command line on a Linux box. Now, if you'd like to know a little bit more about how to do this, or you want to follow these steps yourself, check out my blog. I got a blog post on how to put all this together yourself. All the commands are right there. Also, how you get Docker up and running on your host. That's pretty much it for me today. I'd like to thank vBrownbag, and thank you all for coming out to learn a little bit more about Docker.